Hi everyone, welcome to TitanClass. On this episode of TitanClass, we're going to do a whole bunch of polynomials. Part 1, operations with polynomials, so more like adding, subtracting, combining like terms. Part 2, binomial theorem. Love doing the expansion on binomial theorem. I know you actually don't. That's okay. And then part 3, long division and synthetic division. Let's get started. So part 1, operations with polynomials. What we're doing here is we're really just taking the addition or subtraction of multiple terms and combining like terms and putting them together. The key is when you have subtraction or if there's an operation with function notation, make sure you do those first and then combine. Let's get started. Number 1. So I've got 5n to the 4th minus 3n squared minus 3n to the 3rd minus 2n squared. Okay, so no function notation here, there's no f of x or g of x, but it's subtraction. So remember when there's a minus sign in between these two parentheses, I have to distribute. So that negative sign or that minus sign is going to distribute to both of those terms on the right-hand side, and all it's going to do is it's going to change both of those signs. So let's go ahead and rewrite with no parentheses. 5n to the 4th minus 3n squared doesn't change at all. But now this sign is going to become a minus, so negative 3n to the 3rd. And that one's going to turn to a plus 2n squared. Now that I've distributed and the parentheses are gone, I can go ahead and combine like terms. So 5n to the 4th is part of my answer, right? Because there is no other 4th power. I've got a negative 3n to the 3rd, which stays part of my answer because there is no other 3rd power. And then I have a negative 3n squared plus a positive or positive 2n squared, which is just negative n squared or negative 1n squared. This is my final answer. Now also, something to be careful of when we have polynomials. Make sure that it's in standard form. And standard form is descending exponent order. So it has to be from the highest exponent down to the lowest. This is definitely in that 4, 3, 2. So standard form, descending exponent order. This is correct. So number 1, and I'm going to have to move over just a little bit. 5n to the 4th minus 3n to the 3rd minus n squared. All right. Got a couple more like this in this section, but we also have some function notation to talk about too. All right. So number 2 is 5x minus x squared plus 8x minus 7x squared. Hey, where are you going, Titan? You bored? We just got started, bro. Plus sign in the middle. When there's a plus sign in the middle, they never distribute, right? So the plus sign just means, well, I can drop the parentheses and just solve it or combine like terms from there. So let's drop the parentheses, 5x minus x squared plus x squared minus 7x squared. Remember, plus signs never distribute, only minus signs do. So let's combine like terms. I've got a 5x and a 8x, which is 13x. I've got a negative x squared and a negative 7x squared, which is negative 8x squared. Now, be really careful. Mathematically speaking, this is a correct answer, but it's not in the proper form. We have to make sure it's in descending exponent order. Remember, biggest exponent comes first, then the next one. So we're going to have to rearrange these two things. Negative 8x squared comes first, plus 13x comes next. This is proper, and that is my final answer. That blue doesn't circle well. That's stinky. Number 2, negative 8x squared plus 13x. Okay, let's keep it going. Remember, plus signs do not distribute, minus signs always distribute. Okay, this one is f of x. I don't know how he got downstairs so fast. He was literally standing right there. 5x minus 2x to the 3rd. And then g of x is 8x minus 2x to the 3rd. Be right back. Okay, So I've got f of x and I've got g of x. I'm out of breath because I ran up and down the stairs. Titan decided to rip up the carpet. He didn't actually rip it, he just like moved it, but he knows that I hate that, so way to go, buddy. Thanks a lot. Okay, f of x and g of x. Now, we have to be careful about what it asks us to do. In this particular case, it's saying to do f of x minus g of x. All right, well, that means I'm going to subtract. Just be careful about how we order these things, right? It does say f of x first, and then it says g of x. So just do what it asks to do. Put f of x first, then subtract it from g of x. Remember though, wow, I need to run up and down the stairs more often, probably. Thanks, pal. We're going to distribute the minus sign, so we put parentheses around everything. So, God bless you. 5x minus 2x to the third minus 8x minus 2x to the third. Okay, so again, do exactly what it says. Rewrite the f of x, rewrite the g of x, and go from there. Distribute the minus sign to both terms on the right. 5x minus 2x to the third minus 8x plus 2x to the third. It's going to be interesting. Both of the 2x to the thirds cancel because there's a minus and a plus. So then I just have negative 3x, which is the final answer. No need to reorder, obviously, because it's already one term. So number 3 is going to be negative 3x. And that sometimes happens where a lot of the stuff cancels out. Just be careful there. Okay, 2 more in this set, then we'll move on to multiplication, which is actually very easy. Okay, what was this one? Okay, another function notation. So we have g of x equals 3x to the fourth minus 9x squared, and then h of x is x to the fourth minus 2x squared. Okay, now we have a g of x and an h of x. Don't worry about the letter that's in front. That's just another way to identify a separate function, right? So what does it ask us to do? Okay, it says to do h plus g of x. Okay, so this is another way that you can see operations. It's exactly the same as the thing we just did, but this is a plus. So it says take the h function, add it to the g function. Now, why is the x by itself in parentheses? It just means in terms of x, meaning we're not going to do anything funky. We're just going to do the addition like it says. Add the h and the g function together. So because it's plus, I don't even have to put parentheses. All I have to do is make sure I combine like terms. So h is x to the fourth minus 2x squared, and g is 3x to the fourth minus 9x squared. Okay, so again, we're adding so I don't have to put parentheses at all. X to the fourth plus 3x to the fourth is 4x to the fourth. And then negative 2x and negative 9x is negative 11x squared. Take a look to make sure it's in proper order. 4x to the fourth minus 11x squared is in proper order, which is my final answer. Okay, so I've got 4x to the fourth minus 11x squared is my final answer there. All right. One more problem in the set, and then we'll move on to multiplication. And the multiplication part we've done before on this channel, but it's more like making sure that you know the function notation. That's probably going to be the biggest problem or the biggest change. Okay, g of x is, oh, actually g of a. That's weird. It doesn't matter. It's just a different variable. G of a equals 6a to the, that is a second power. It's hard to see. Sorry. G of a equals 6a to the second power minus 5, and h of a is 2 minus 4a squared. Okay, and it tells us to do h minus g of a. Okay, so again, we have two different functions, and they're just labeled by different letters, so it's just two different functions. Don't worry about the letters so much. Now it's saying to do h minus g of a. Now, really careful here. It's minus, so we're going to have to put both things in parentheses, but don't just put them in the order that they were given to you. H needs to come first here, because in subtraction, the order matters, so just be really careful here. I'm going to write the h function first, so 2 minus 4a squared, minus the g function, 6a squared minus 5. Distribute the minus sign, and then we'll go from there. And if you're saying to yourself, well, what's the order matter? Why does it make a difference? It makes a huge difference, right? Because, you know, 3 minus 1 is 2. where 1 minus 3 is negative 2. So order is really important in these types of things, right? So just be careful when we do subtraction problems. 2 minus 4a squared minus 6a squared plus 5. Ooh, I jumped ahead too many steps. Minus the quantity of 6a squared minus 5. Now let's change both signs by rewriting. Oh. Get a boo-boo. Let's focus, bro. I don't really want to edit this out because it's important that I show you this, I think. Whatever. So let's distribute the minus sign. Okay, so let's actually distribute the minus sign. 2 minus 4a squared, hi, brain work. Minus 6a squared plus 5. There we go. Now we can combine like terms. I've got a positive 2 and a positive 5, which is a 7. And then I've got a negative 4a squared and a negative 6a squared. Sometimes you might be thinking to yourself at home, like, what is he doing? Like, is he okay? No. Minus 10a squared, the answer is no. Now, is this in proper form? No, of course not, because the exponent, the only thing that has an exponent is behind. It has to be in the front. So the true answer here is negative 10a squared plus 7. Final answer. Okay. Number 5 is negative 10a squared plus 7. Okay, so that wraps up my addition and subtraction or combining like terms of polynomials. Just be careful of minus signs and be careful of descending exponent order, which is called standard form. Okay. Also, one last thing before we move on. For number 1, what would be the leading coefficient of this polynomial? Remember, the leading coefficient is the first term's first number. So the leading coefficient in number 1 would be 5. What would the leading coefficient be of 2? Negative 8. Negative 3, that's the only coefficient, right? 4 would be 4, and then for 5, it would be negative 10. So if I ask you, or someone asks you, or your teacher asks you, or your dog asks you, what's the leading coefficient of these things? Just know it's the first term in the front. Now, one more thing, or one additional thing, is what kind of a polynomial is it? Well, you can just say how many terms it is, right? So number 1 is a 3-term polynomial. We also call that a trinomial, but that's not super important. Number 2 would be a binomial or a 2-term. Number 3 is a 1-term, 2-term, 2-term. Okay. No, I don't want to do that. Let's do some multiplication. Not many. Number 6. So 2p plus 3 and 8p minus 7. Okay, so when we multiply or FOIL, right, we want to use the area model. It's way easier. Now, the reason we're going to use the area model here is because these can get a lot more funky, meaning I could do like a 3-term times a 3-term or a 3-term times a 2-term, and we'll do that very shortly. So we're going to make our area model box, and then we're just going to put on the top the first pair or first set of parentheses, 2p plus 3, and on the side, we'll put the other one, so 8p minus 7. So then we'll multiply through. 8p times 2p is 16p squared. 8p times 3 is 24p. 2p times negative 7 is negative 14p. And 3 times negative 7 is negative 21. And then we'll combine like terms and write it out. 16p squared is the only thing with a square term. 24p and negative 14p will combine, which gives me a positive 10p. And then minus 21. Final answer is 16p plus 10p minus 21. Okay? And again, we've done these on this channel before, where it shouldn't be too challenging to remember how to do these. But I will give you one more before we move on to something a little harder. Okay? And I'm going to have them in my boxes again, which is fine. I need the exercise to draw boxes. Yeah. Number 7. Okay. All right. 7x minus 8 times 6x minus 3. Okay. Area model again. This marker's running out. 7x minus 8 on top, and then 6x minus 3 on bottom. 6x times 7x is 42x squared. 6x times negative 8 is negative 48x. 7x times negative 3 is negative 21x. And negative 3 times negative 8 is positive 24. Now we can combine like terms. 42x squared is the only thing that's got a square term. Combining these will actually give me a negative 69x plus 24. Final answer, number 7. 42x squared minus 69x plus 24. Is that right? I feel like I multiplied these wrong. Okie dokie. Number 8. Now we're going to do a 2-term by a 3-term, right? And that doesn't really change anything. It just makes it a little bit more complex, right? So for number 8, we've got this. 4k squared minus 4k plus 2 times 5k plus 6 parentheses. Okay, so we're still multiplying these two things, but my area model now can't be a 2 by 2. It needs to be a 3 by 2, right? So we'll just make a rectangle type thing so we can have more space. And make sure you just divide it into a 3 by 2, right? So I think we're gonna have to retire this marker. Obviously put the 3 term on the top. Negative 4k, 2, 5k, 6, multiply out. So 5k times 4k squared is 20k to the third. So be careful. When we multiply exponents together, we're going to add them. 5k times negative 4k is negative 20k. And then 5k times 2 is 10k. Right? 4k squared times 6 is 24k squared. 6 times negative 4k is negative 24k. And 6 times 2 is 12. Now, the diagonals should often, this is a square, be the same. See, hopefully you caught that before I did. So the diagonals should always line up together where you would be able to combine those terms. And they do in this case too. So my final answer is going to be 20k to the third. 24 minus 20 is positive 4k squared. Negative 14k plus 12, and that's my final answer. Because again, I have to combine like terms, and the two sections in the middle that are diagonal of each other are going to combine. Right? So final answer for number 8 is 20k to the third plus 4k squared minus 14k plus 12. You can't see the plus 12. It's okay. I'll try to fix it. Plus 12. That's better. Okay. 2 more like this, I think. And then we'll go from there. Oh, these are function notation now. That's good. Number 9. Got really. What happened here? Huh? It's like more dim in here. That's weird. Wake up. Not you, Titan. The lights. It's weird. I feel like it's darker in here. Okay. F of x equals, so stupid. F of x equals 7x squared minus 6x minus 8. And g of x equals 3x plus 8. Okay, and it says to do f of g of x. Okay, now, this is again is function notation. Now that little dot is actually, it is a multiplication sign, but it's more of like composed. It's a composite sign. It just means to do what it says to do, multiply f times g. So I'm gonna multiply f times g, and whenever we multiply, we are gonna use the area model. So let's go ahead and do that. So our area model again is gonna be a 3 by 2. So 7x squared minus 6x minus 8, and then 3x plus 8. 3x times 7x squared is 21x to the third. 3x times negative 6x is negative 18x. 3x times negative 8 is negative 24x. 7x squared times 8 is 56x squared. Negative 6x times 8 is negative 48x. And negative 8 times positive 8 is negative 64. And again, I made that same mistake twice with the 2. Believe that? Whew. My diagonals should always combine if they're set up correctly. Let's put this over here. So I have a 21x to the third plus, oh boy, 38x squared minus 72x, these are big numbers, minus 64, that's my final answer. Okay, so just be careful of your multiplication. Don't make a silly mistake on multiplication. You won't be able to afford it if it's on like a quiz, test, or other thing. I'll try to make sure I fit this because this is a big number. Oh, it'll fit nice. Okay, one more in this section. And then we'll move on to binomial theorem, which I know everybody's waiting for. You're not. I'm not. It's like yellower in here. Come on, camera. Huh? Yeah! Ooh, that's weird. Huh. These lights are like white. I don't understand why it's like so yellow. You see that? It's weird, right? I think the dog had something to do with it. Number 10. I don't really want to use B. I'll change it to X. Oh, look, it's not yellow anymore. This stupid camera. I'll fix this. I'll fix this. G of X is 5x squared minus 2x plus 5. H of X is 6x plus 6. Okay. Now it says to do h of x times g of x. Okay, so that's actually really simple. So this function notation is really straight up, just multiply h times g. It doesn't matter the order because multiplication doesn't matter the order, right? Just like addition, doesn't matter the order. So we'll still make our 3 by 2 box in this manner. If you really wanted to make it a 2 by 3, right, and make it more long, like tall, that's fine. 5x squared, I know what you're thinking. Is he going to make the same mistake in the middle box again? Probably. 6x times 5x squared is 30x to the third. 6x times negative 2x is negative 12x squared. See, I didn't. 30x, told you. 30x squared. Watch, I'm going to make some other silly mistake. Negative 12x and then 30. Okay. My middle ones should combine. I've got a 30x squared, or to the third, plus 18x squared, plus 18x, plus 30. Final answer. Okay. All right, number 10, we're done with this section. 30x to the third, plus 18x squared, plus 18x plus 30. I know you can't see that, but I'm going to get rid of it anyway. All right, finish with adding, subtracting, and multiplying polynomials. All right, just be careful of the function notation, and be careful. Be careful. Be careful of your minus signs. All right, let's get rid of this marker. Let's move on to binomial theorem. Okay, so when we talk about binomial theorem, we obviously need to also talk about Pascal's triangle, right? So one thing to remember about Pascal's triangle is you don't have to remember anything about Pascal's triangle. All you need to do is be able to complete it to whatever level you want to do. Just remember this. It always starts with 1, and then all of the sides, like the sides of the triangles, have got to have 1s, right? Then you just add, right, the 2 middle pieces to get that, right? So for example, a 1 goes here, and then a 3 goes there because it's in between a 1 and a 2. It's only addition, that's all it is, right? And then this 2 and this 1 are 3, and that's a 1, and I'll do one more. 1, 4, because 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1, I think Titan farted, is 4 and a 1. It's disgusting. Oh gosh. I think I need to evacuate. Oh. This room is not terribly large, so even with the door open, bro. Oh, so foul. We can continue on from there. Oh God. Send help. Send help. It's terrible. Oh. He's like 5 feet from me too, and it's just like wafting. Ugh. Okay, so binomial expansion. So there's not many of these because they take a long time. So this one is going to be, where is this one? X minus 4 to the 4th power. Okay, so the 4th power indicates what level of Pascal's triangle I need. The 4 exponent, that will always correspond with the second number in that row. Now, we could always remember like level 1, 2, 3, 4, 5, 6, because it starts at level 0, which is weird. But if you just remember what the second number is, then you know what it's going to be. And then if you look at Pascal's triangle, which you probably will be given on anything that you do, the 4th exponent needs 5 digits, because it always needs 1 more. And then 4 is the middle number, or the second number, right? So let's go ahead and do this one. So we start with the 1, and we multiply that by the first value in the parentheses, which is x. We always raise that first thing to the highest power, which is 4. Then we're going to multiply the second thing, or second term, in there. And because it's a negative, I want to put it in parentheses. And we raise that to the 0 power. That's our first set, right? So 1, which is the first coefficient, x to the 4th, which is the first term to the highest, times the second term, -4, to the lowest exponent. And then 4, 0 will go 3, 1, 2, 2, 1, 3, 0, 4. And you'll see that as we go. Add in between, because the negatives will take care of each other as we go along. This is going to be a 4, right, because the next exponent, or I'm sorry, the next coefficient, times x to the 3rd now, right, because I'm going to go down one level, times parentheses -4, now it's to the first power. So you see what I mean? X to the 4th, then x to the 3rd. Obviously, next will be x to the 2nd. -4 to the 0, -4 to the 1. So they just really flip-flop in the order. Plus, next value of the coefficient is 6. X to the 2nd times -4 to the 2nd there. Okay. Plus, now I know there's a lot of different ways you can do these problems. I know that there's like this box kind of method that you fill in. I'm not a huge fan of that method, but it does work. So if you need things to be a little bit more organized, then you can use that kind of layered box method, which I'm not super familiar with, so I'm not going to do it here. But you can search for that. Okay. So what am I doing here? I'm going 2, 2, 1, 3, and then the last one will be a 1 times x to the 0 times -4 to the 4th. All right. So take a look. There is a pattern, obviously. 4, 3, 2, 1, 0. 0, 1, 2, 3, and 4, right? Now we're just going to simplify all these things. The -4 to the 0, anything to the 0 power is just 1, so it cancels essentially. So this just becomes x to the 4th. Plus, actually, it's not a plus. So this is going to be a -4 to the first power, which is -4. -4 times 4 is -16, so this is going to be a -16x to the 3rd. All right. Next, this will be a plus. So -4 squared is 16. And 16 times 6 is 96. Don't forget the x squared. -4 to the 3rd power, that's -64. That's why we put this in parentheses, so you don't make a silly mistake with the negative sign, because the negative sign does matter. So this is -64 times 4. I want to say that that's 256, but I don't want to make a silly mistake. So -64 times 4, -256, x. The first power, or just x, so don't forget that. And then -4 to the 4th power is 256. The x cancels out. So my final answer is here. Now, sometimes you'll see it as expand the entire thing, which is what this is. Or sometimes it'll say find the 3rd term. Well, the 3rd term would be 96x squared. Sometimes it'll say find the 4th term or 5th term or whatever. So you can go ahead and expand the whole thing. I think that's safer. And then find out which term it wants. It also may say find the coefficient of the 2nd term. Well, the coefficient is the number in front, -16, right? Or find the coefficient of the 4th term, -256. So there's a lot of different ways you might see it. It's 3 different ways, right? Number 1, it'll say expand the entire thing. Number 2, it might say find a specific term. Or number 3, it might say find a specific coefficient. Either way, I think it's safer just to go ahead and evaluate the whole thing or expand the whole thing so you don't make a silly mistake, right? Now, I'm not going to write the, maybe I will. Maybe I will. Don't be lazy. I'll just write it. I wasn't going to write it because it's a lot, but I'll write it. I don't want to be lazy. This is 11. X to the 4th minus 16, x to the 3rd plus 96x squared. Did I give myself enough space? We'll find out. I'm getting close. Look at that. Okay. Got a couple more like this. Not too many, because these take a long time. Okay. So these are binomial expansions. And really, it takes time, but just make sure you don't make a silly mistake with the multiplication part of it. Okay. Actually, we can just do one more. Okay. Now this one is number 12, and it says to find the 4th term. Okay, so I'm just going to expand it until the 4th term, and then I'll go from there. So this is a difficult one, right? So this is going to be 3x minus 5y to the 5th power. Oh boy. All right. So the first thing I need to know what level of Pascal's it is, because Pascal gave me the coefficients. Remember that 5 indicates two things. It means the second number is a 5, and it's going to have one more term. So it's going to be 6 terms here. This is 1, 5, 10, 10, 5, and 1. Ugh. Okay, now I only want the fourth term. So once I get to that fourth 10, or that fourth number, I can stop, because I don't need to go any further, because I only want one specific term. So let's go ahead and do this. 1 times, now we're going to have to put both of these things in parentheses, and I'll explain that as I go. 3x to the 5th power times negative 5y to the 0 power. The reason we're doing this is really, really important, actually. When there is a coefficient on one of these values, the exponent is going to distribute to not only the x or y, but also the coefficient. So this is going to be 3 to the 5th times x to the 5th. So we have to separate these things, because you're not going to know how to do it otherwise, right? When we distribute exponents, it distributes in this manner, so just be really careful. And also, this one has a negative, so we have to be doubly careful, right? That's going to be my first term. Now, I actually don't have to evaluate that, because that's unimportant. But let's keep going. 5 is my next coefficient times 3x to the 4th times negative 5y to the 1st. Again, second term, I don't even have to evaluate it though, because all I want to evaluate is that number, or that term at that number. Okay, plus 10 times 3x to the 3rd times negative 5y to the 2nd. Again, I don't need any of these. I only have to evaluate the last one, which is this one coming up. 10 times 3x to the 2nd power times negative 5y to the 3rd power. That's what I need to evaluate. Okay, so let's go ahead and evaluate it. This is going to say 10 times. Now the 2 distributes to the 3 and to the x, right? So because it's distributive property. 3 to the 2nd power is 9. X squared is x squared, right? X to the 2nd power is x squared. This one's even messier. Negative 5 to the 3rd power. Well, negative 5 to the 3rd power is negative 125 times y to the 3rd power. This is what we're evaluating. So let's go ahead and just put our x squared y to the 3rd down, because that's not going to change. We're multiplying 10 times 9 times negative 125, because that's a mess. 10 times 9 times negative 125 is a huge number. This is terrible. Negative 11250 x squared y to the 3rd. That's my final answer. So what did we do here? First, we knew we were going to have a big number here, because these values, anytime we have like numbers bigger than 2, really, raising to a 5th power is going to get really, really, really expensive in terms of how big the number is. So I only wanted the 4th term. I only went through the progression, though, for completeness, because I really wanted to get the 4th term through this process, and then we finally just got the 4th term and evaluated it. So number 12 is going to be negative 11,250 x squared y to the 3rd power. Ugh. It sucks. Anyway, all right, let's move on. Part 3, long division and synthetic division. Long division is the stinky type, but synthetic division is the fun type. And yes, I'm being serious. Synthetic division is fun, because it's easy. I want to get rid of this marker. These markers are dying on me, Titan. Huh? Why don't you get a job and give me some more markers? I'm sorry, I didn't mean that. Number 13. Oh, that's better. Okay, so we're going to do some long division first. Now, long division has 2 types, obviously. We can have remainders and we cannot have remainders, right? All right, here we go. We don't actually have that many of these. Okay, so I want to do x to the 4th minus 5x to the 3rd minus 57x squared minus 41x minus 30 divided by x plus 5. Okay, oh boy. X plus 5 is the divisor, right? So we're going to do x plus 5, and then we're going to do x to the 4th. I probably should have just written this the first time. The right way, minus 57x squared minus 41x minus 30. Okay, so with long division, how many times we started off by, how many times does x, or the variable, fit into this first term, meaning divide? How many times does divide evenly into that number? Well, that's x to the 1st That's x to the fourth. It only divides in 3 more times, right? So x to the third goes on top. Now we start the process of multiplying through. X to the third times x is x to the fourth. X to the third times 5 is positive 5x to the third. Now, we have to switch the signs in order to get rid of the first term. That's going to become a minus, and so is this, right? We're always going to change the signs of both of those terms. That's going to cancel, and this is going to leave me with negative 10x to the third. Before we move on, we've got to drop down the next level, negative 57x squared. Okay, start the process again. How many times does x fit into negative 10x to the third, or how many times does x divide into negative 10x to the third? Negative 10x squared times. Okay, then multiply through. Negative 10x squared times x is negative 10x to the third. Negative 10x squared plus 5 is negative 50x squared. Again, change both signs. These are nice because I can just put pluses there. That cancels, and then we add down, which gives me a negative 7x squared. Before we proceed, bring down the next term, negative 41x. Start the process again. How many times does x fit into negative 7x squared? Meaning how many times does it divide? Negative 7x times. Multiply through. Negative 7x times x we knew was already negative 7x squared. Negative 7x times 5 is negative 35x. Okay, change both signs, crosses out, subtract. Negative 6x, negative 30 drops down. Start the process again. How many times does x fit into negative 6x? Well, it fits in negative 6 times. Multiply through, negative 6x minus 30. Change both signs, both cancel, remainder of 0. Final answer is the quotient up top. Number 13 is x to the third minus 10x squared minus 7x minus 6. Done. Okay? Long division, it's just the process being like cyclical, like a cycle, right? Over and over and over again. Okay, we're going to do one more like that, and then we'll go ahead and do some synthetic stuff. This one doesn't want to erase. Okay. That was a fourth power. Let's do a third. R to the third. Now I'm just going to go ahead and put it into the long division problem straight up. So let's go r plus 6. And that's going to divide into r to the third minus 4r squared minus 56r plus 24. All right. Process starts with how many times r fits into r to the third, and it fits in r squared times. Multiply down to get our two values underneath. R to the third plus 6r squared. Changing the sign of both, so that's a minus, and this is also a minus. Cancels, negative 10r squared. Drop down the next value, negative 56r. How many times does r fit into negative 10r squared? And that's going to be a negative 10r times. Multiply through gives me negative 10r squared minus 60r. Change both signs. Drop it down as a 4r. Positive 24 comes down. R fits into 4r 4 times. Multiply through. Change both signs. And they both cancel. Leaves me with 0 remainder. The quotient is up top. R squared minus 10r plus 4. Okay. All right. Now, actually, before we get into synthetic, let's do one with a remainder, just like this. Okay, number 15. I'll do one with a third. So let's do n to the third. Oop. I don't want to waste time with that. I'll just put it into the divisor. N minus 8 divides into n to the third plus n squared minus 81n plus 62. Okay, so this is going to have a remainder, but you wouldn't know that yet, really. It's really simple to just add the remainder onto the back. N fits into the n to the third, n squared times. Multiply back down, gives me n to the third, and then negative 8n squared. Change both signs. This is 9n squared. Drop the negative 81n down. n fits into 9n squared 9n times. Multiply back through, negative 72n. Change both signs. Cancels negative 9n. Drop the 62 down. N fits into negative 9n negative 9 times. Multiply through, and this is going to give me, changing both signs, I mean, a negative 10. Now, the negative 10 is the remainder because there's nothing else that I can create to drop down. What we do with that is we put a minus for the negative next to the last number we put up here. 10 goes in the numerator, and the denominator is our original divisor. This is my final answer. N squared plus 9n minus 9 minus 10 over n minus 8. And again, the reason is because there's nothing else that we can create to drop down, so we actually have to stop there, right? So this is division's way of saying no more. So n squared plus 9n minus 9 minus 10 over n minus 8. Final answer. Okay, so that's long division. Let's do some synthetic, which is a lot faster and a lot better, right? Okay. Okay, number 16. Number 16, and we'll do one that has no remainder. So let's say that I said that we needed to use synthetic division for this problem. B to the third plus 6b squared minus b minus 30 divided by b plus 5. Okay, well, with synthetic division, first we need to find an answer to this factor. So this is a factor of that polynomial, meaning if we were to factor this, we would get b plus 5 as one of the factors. So we want to set this equal to 0 and solve. Now the reason for that is because we need one independent number, not affiliated with a letter, to put in our little perch, our little balcony here, right? So if I were to solve this thing, it's negative 5. Or if you just want to look at this, it's just the opposite sign. So negative 5 is going to go in my little balcony here because that's the value that we're going to keep referencing. Then onto the side here, we're going to put our coefficients and our constant value. 1, 6, negative 1, negative 30. Draw a little line, draw an arrow to bring that 1 down, and we can start our process. This is multiplicative. Negative 5 times 1 is negative 5. Now we find the difference. 6 minus 5 is 1. 1 times negative 5 is negative 5. Find the difference, or we're going to add now. Negative 1 plus negative 5 is negative 6. Negative 5 times negative 6 is positive 30. And that cancels, which is a 0 remainder. Now, we had a third power, but when we divide out, we're going to drop 1 power less, or 1 more power down. So that 1 represents b squared. That 1 represents positive b, and that is a negative 6. The answer to when I divide these two things is b squared plus b minus 6. Okay? So we had a third power, we have to drop down 1 level to a second. So our answer with synthetic, which is way faster than long division, is b squared plus b. I wrote 6 when I said plus b minus 6. That's synthetic. Let's do another one like that, and then we'll do one with a remainder. And I think I have a weird one on here that I like to do as well. Okay, now remember, we want to do these things in order. You have to put the coefficients in order of what the exponents show. So number 17. Did I do that one already? I don't think I did that one. Okay, so I have 8x to the third minus 35x squared plus 20x minus 32 divided by x minus 4. Okay, synthetic division says I need the opposite sign of this, so it's positive 4. And that goes in my balcony. Now, I'm going to put the coefficients in order of the exponents. So the third exponent has an 8. The second exponent is a negative 35. The first exponent is a 20. And the last number constant is a negative 32. Line underneath, drop the 8 down to start this process. 4 times 8 is 32. The difference is negative 3. Multiply is negative 12. The difference is 8. And multiply is 32. We have a 0 remainder again. It started as a third power, now it's a second. So this is 8x squared minus 3x plus 8, final answer. Okay, the 0 remainder we don't do anything with, obviously, because it's a 0. And that's number 17. So 8x squared minus 3x plus 8 is my final answer. Okay, let's do one that has a remainder. And then I have one more problem I think I need to do with you. This is a long video. because these things take a little while to do, especially binomial theorem. All right, number 18. Okay, n to the third plus 11n squared plus 33n plus 34 divided by n plus 7. Okay. It's going to have a remainder, but it's synthetic division, so it should be relatively easy. If it's n plus 7, we want a negative 7 in our balcony. So let's do 1, 11, 33, 34, line down, drop the 1 down to start the process. Negative 7 times 1 is negative 7. The difference is 4. Negative 7 times 4 is negative 28. 5. 5 times negative 7 is negative 35. The remainder is negative 1, so we're just going to leave that to the side for now. It started as a third, so it's going to end up as a square. N squared plus 4n plus 5 minus, just like in long division, whatever the remainder is goes in the top of a fraction, and the original divisor goes in the bottom. That's my final answer for number 18. N squared plus 4n plus 5 minus 1 over n plus 7. Okay. One more weird problem to do, and it's synthetic. Okay. You'll see what I mean in a second, I hope. I actually don't know if this is going to work or not because I'm creating it off the top of my head. Okay. X to the third plus 6x minus 8 divided by x minus 2. Okay, synthetic division. But what's wrong here? What is a little different than what we've done in the past? Well, the divisor looks pretty legit, but take a look at what's happening with our exponents here. I went right from a 3 to a 1. There's no 2. Like there's no exponent of 2, which is actually a huge problem. So when we are missing a term, because we're missing the square term, we still have to pretend like that term is there in order to do synthetic division correctly. So here's what I mean. Plus 2 or 2 is the number in the balcony. Right? There's no debate about that. Now, when I write this out, we put our coefficients in order, even though there's no square term. 1 is the coefficient of the third term. Again, there's no square. There's no term with an x squared on it, which means that that term is 0 because 0 canceled it out, so it's not there anymore. Then it's 6, then it's negative 8. Okay, so here's how this works. The first term's coefficient is 1. The second term is not there because a 0 canceled it out. We have to pretend like a 0 canceled it out, which means that that term would have been 0 for it to go away. Then a 6, and then a negative 8. Okay, so it's actually the same process. We just have to account for that missing variable. And variable. 2 times 1 is 2. 0 and 2 together is 2. 2 times 2 is 4. That's 10. 2 times 10 is 20. Negative 8 plus 20 is 12. That's our remainder. Now, we had a third power. We're just going to drop one exponent down, but we're going to go in order of x squared, then x, then the constant term, then the remainder. So this is x squared plus 2x plus 10 plus 12 over the original divisor of x minus 2, and we're done, right? So be careful. Just because we're missing a term here does not mean we are missing a term here. That will never happen, okay? So make sure you put a 0 remainder or 0 placeholder for the x squared term, and then we'll be done. Thanks for watching this episode of TitanClass. See you next time.